Strength behavior of iron fillings in concrete by partial replacement of sand. Rajeswari v. M.E. Structural Engineering. M.A.M. College of Engineering and Technology. Tiruchirappalli, Tamil Nadu. Abstract. The utilizing of iron fillings in concrete as a partial replacement of sand is attaining enormous significance nowadays, mostly because of improvement in strength of concrete and environmental benefits. The aim of study is to assess the possibility of applying iron waste in different percentage, 20%, 25%, 30%, 35%, as fine aggregate replacement of sand to increase the strength of concrete. For this purpose, the mix proportion was designed as M20, 1:1.5:3, for giving the compressive strength. To achieve the goal of study, laboratory experiments, compressive strength, and flexural tensile strength were conducted to determine the influence of iron filling sand. The strength of concrete.Higher content of iron fillings particle replaced in concrete increases workability of concrete. Using iron fillings with 35% of replacement of fine aggregate gives the higher strength than normal concrete mix. Addition of iron fillings in concrete increases the strength characteristics of concrete. Keywords: iron waste, fresh concrete test and hardened concrete test. 1. Introduction. Concrete is the most widely used man-made construction material in world and is second to water as the most utilized substance on the planet. A major portion of this concrete volume is occupied by coarse and fine aggregate. The demand for aggregate is enormous in liberalization, privatization, and globalization, and in the construction of important infrastructure projects like expressways, airports, nuclear plants, etc. The increased extraction of coarse and fine aggregate from the natural resources is required to meet this high demand. The increasing use of natural fine aggregate creates an ecological imbalance. Thus, partial replacement of fine aggregate is vital in construction industries. Aggregates are the most important constituents in the concrete mix that help in reducing shrinkage and impart economy to concrete production. Iron filings have some utility as a component in primitive gunpowder. In such a fine powdered form, iron can burn, due to its increased surface area. 2 objectives. To understand the various application involved in iron fillings. To perform laboratory tests that are related to compressive and tensile by use of iron fillings in concrete. To improve strength characteristics of concrete with iron fillings. 3. Methodology. Collection of materials. Testing of materials. Arriving mix design. Casting and curing of specimen. Testing of specimen. Result. Conclusion. 4. Materials and tests. 4.1 Cement. Ordinary Portland cement of 43 grade conforming to IS 8112-1989 is used for these experiment. The physical properties of cement is shown in the table 1. S.No. Property. Result. Permissible. 4.2 Sand. Natural river sand from Kaveri river bed near Trichy, Tamil Nadu classified under Zone 3 is used in this experiment. A physical property of fine aggregate is shown in the table. Point 2. Table. Point 2 Properties of fine aggregates. S.No. Property. Result. Permissible. 4.3 Coarse aggregate. The size of the aggregate, particle shape, color, surface texture, density, impurity, all of which have an influence on the durability of concrete, should conform to IS 2386, Part 3. 6. 6.1 Compressive strength test. The compressive testing machine was used to test the entire concrete strength at 7, 14, and 28 days respectively. The compressive strength for concrete grade M20, 1:1.5:3, were investigated for the control mix and while cement was partially replaced by iron fillings. The result of compressive strength test at different curing periods is provided in table. Through the laboratory observation it was perceived that early age strength is lower than the later age strength, because concrete gain its strength with the passage of time. Compressive strength equals breaking load, N, area of cube, mm2. 6.2 Split Tensile Strength Test. The tensile strength of concrete is one of the basic and important properties which greatly affect the extent and size of the cracking in structures. Moreover, the concrete is very weak in tension due to its brittle nature. Hence it is not expected to resist the direct tension. So, concrete develops crack when tensile forces exceed its tensile strength. Therefore, it is necessary to determine the tensile strength of concrete to determine the load at which the concrete members may crack. Split tensile strength equals 2 ppdl. 7. Conclusion. From the results and discussion it was concluded that higher content of iron fillings particle replaced in concrete increases workability of concrete. Using iron fillings with 35% of replacement of fine aggregate gives the higher strength than normal concrete mix. Addition of iron fillings in concrete increases the strength characteristics of concrete.